Hey all, we are here today. We're going to be doing lesson 49. This is Algebra 2, and we are doing lesson 49. All right, in lesson 49, what we want to look at first is remembering that we can write an equation by looking at a line. So if I've got a plane here, a coordinate plane, and say this is 2, and this is 1, 2, 3, okay, and I have a line that's going right through here. And we're asked to write the equation for the line. Well, we think about our y equals mx plus b. Okay, I can figure out the slope of the line. So if I'm over here on 3, I go up 2 and over 3 towards the negative. So my slope is going to be negative 2/3. Okay, I also can find here the fact that the y-intercept, it intercepts y at 2, so b is going to be 2. So my equation of this line is going to be y equals 2/3 x plus b. All right, so I can do that when I can see my line and I'm able to look at this and I can see where it intersects the y-axis. Okay, so let's say I have something here. All right, and let's look 1, 2, 3, 4, 5, 6. So this is going to be 6. And let's say we have 1, 2, 3, 4. Okay, and I have a line that goes like this. Okay, and I can't see where the line intersects the y-axis. All right, so I can't see that, but I can see that there's a point right here. If I had done this on an actual piece of graph paper, we would see right here that this point, the value of x is 3 and the value of y is 6, right? Okay, and down here, the value of x is 4 and the value of y is 0. Okay, so we can see here that as far as my slope goes, I go over 1 and up 6, okay? This 3 and this 6 and this 4 and this 0, and if I subtract them, I get my change here is a -1 and my change here is 6, okay? So I'm rising up 6, I'm running over 1, so my slope is going to be -6 or -6 over 1, okay? I don't know what my y-intercept is, but I do know some points, like specifically I know this 4 and this 0, so I can go ahead and plug those in place of x and y. So, I've got my y equals mx plus b, okay? I can plug in the -6 for the m, all right? And then for the y, I can plug in a 0. For the x, I can plug in a 4, and I'm going to solve for b. So 0 equals -24 plus b, and so b equals 24. So the equation for this line is going to be y equals -6x plus 24. Okay? All right, let's look at another one real quick. All right, let's look at another one real quick. If I have, let's look at this. I have this. I have this. Okay, let's see, we're over here on the -3. And if I again came up here to 1, 2, 3, 4, 5, 6, okay, and I let this go kind of this way. Okay, such that, there's a point right here, which is -1, 6. Okay, and those intersect right there. So I'm able to get two different points. Down here, I have -3, 0, and up there, I have the -1 and the 6. So I can see the idea that I'm going to rise up 6, I'm going to run over 2. Right? So I'm going to be up 6, I'm going to be over 2. And if I look at, I've got the 1, the -1 minus the -3 is going to give me 2. all right, and I have the 6 minus 0 is going to give me 6, okay. This over here is my run. This over here is my rise, okay, because these were the x values and these right here were the y values, all right. So I'm going to find that my slope is going to be 6 over 2, which also equals 3, so that's my slope, all right. And then I can just plug in one of the values that I know. So I've got this point right here, the negative 3, 0. All right, so going with my y equals mx plus b. All right, y is going to equal 0. My m is 3. The slope is 3. X is going to be negative 3 plus b. 0 equals negative 9 plus b. So b is going to equal 9. So the equation of this line is going to be y equals 3x plus 9. Good. Okay. All right. The next concept here in this chapter, we're going to deal with some transversals. All right. So here, if I've got, remember the transversal, I have two parallel lines, and they're going to be intersected by another line, right? Okay, so I'm told here that this angle down here is 153 degrees, all right? We're going to call this one Z, all right? We'll call this one P, all right? We're going to come here, drop this line right here. This is going to be a 90-degree angle. This is B. The length of my hypotenuse is 7, and this side down here is going to be 9, all right? And I want to solve this for my different variables for C and P, for Z and P and B. Okay, so let's think about this. The first thing we know for angle Z, Z and this 153, those are going to be supplementary, so they equal 180 degrees, right? So Z equals 180 degrees minus the 153 degrees. So that tells me that Z equals 27 degrees. Okay, so I know now that Z equals 27 degrees. All right, that's how I found Z. We also know, based on the law of transversals, that P and Z are going to be corresponding angles. Sorry, I had to think about that word for just a second. So I know also that Z and P are corresponding. And since they're corresponding angles, I know then that Z is equal to P. So that means that P is also 27 degrees. Okay. All right. So now that I know P is 27 degrees, I can use sine, cosine, tangent, use those, sine and cosine specifically, to be able to solve for A and B. Okay. So my sine, remember, is the opposite over the hypotenuse, and my cosine is the adjacent over the hypotenuse. All right, so the sine of 27 degrees is going to be equal to B, which is the opposite of angle P there. You see that? That here's P, this 27 degrees, and B is the opposite. Okay, so we're going to have B over the hypotenuse, which is 7. All right, so when I key this into my calculator, I find that the sine of 27 is going to be 0.45. So 0.45 equals B over 7. When I multiply both sides by 7, I get that B equals 3.15. And this is an approximation, so it's going to be approximately. All right. For C, I'm going to have that the cosine of 27 degrees is going to be equal to that adjacent angle, all right, which is an A. It looks like a 9. I wrote it as a 9. That should actually be an A. Sorry, guys. So this right here should be the letter A, not the number 9. Okay, so this right here is going to be the adjacent over the hypotenuse. All right, when I key in 27 sine, I find that that is 0.89 is equal to A over the hypotenuse, which is 7. When I multiply both sides by 7, I'm going to get that A is going to be approximately 6.23. All right. So notice how I solved that. I was able to figure out Z because I know these two angles together, they create a straight line. They equal 180 degrees. All right. Then if this one is 27 degrees, P is a corresponding angle, so they're the same measurement, also 27 degrees. Once I knew the 27-degree measurement here, I could then use sine and cosine to solve for the opposite and the adjacent angles. Okay. And let's see, let's run through one more just real quick for good measure. All right, if I've got this, pretending that those are parallel, right? I didn't do a great job with that. All right, here's this. Here I've got an M and a P. I'm going to know that the length of this side is 2, and I know that this angle down here is 150 degrees. Okay, if that angle is 150 degrees, then this angle is 30 degrees. If that angle there is 30 degrees, then I know that this angle in here is 30 degrees. All right, and so now it's the, remember our so, ka, or Oscar had a hold, and then remember on Arthur. All right, so I'm going to be finding the sine of 30 degrees, and I'm going to find the cosine of 30 degrees. And the sine of 30 degrees is going to be equal to P over M. All right, the cosine of 30 degrees is going to be equal to 2 over M. Let's go ahead and put our tangent down here also. Oscar had a hold on Arthur. Okay, and it's so ka toa. Okay, and when we do the cosine of 30 degrees, here we're going to get the opposite, which is P, over the adjacent, which is 2. Okay, notice here, the sine, I've got these two variables, so the sine doesn't help me at all. So this time I'm not going to use the sine because it doesn't help me. I want to use the cosine because I'm left with just one variable there, and I want to use the tangent because I'm left with just one variable there. All right, so here I would punch in the cosine, and I'm going to get that that equals, the 0.87 equals 2 over m, and then I'm going to solve that and find that m is about 2.3. Down here, I'm going to punch in the cosine, not the cosine, this should be the tangent. All right, punch in the tangent of 30 degrees, I'm going to get 0.58. equals P over 2. I'm going to multiply both sides by 2, and I'm going to get that P equals 1.16. Okay? All right, that is it for lesson 49. I hope that helped.